So thanks everyone. I'm Sophie, I'm based at the University of Melbourne and I'm in our newly named Extremes team. And today I'm going to be talking about extremes and climate models. So to begin with, I'm just going to jump in and give a couple of examples of how we use climate models to investigate climate extremes. And then we're going to step back a little bit and look at whether this was a good idea to do in the first place and whether that's a valid way to use our climate models. So to begin with, I'm going to say that models provide us with an opportunity to understand climate extremes, and we're going to talk about, in particular, looking at examples of extreme climate event attribution. So yesterday David was talking about detection and attribution in terms of sort of large-scale long-term changes, like the longer-term greenhouse warming signal that we see, but I'm going to be talking about attribution in regards to particular climatic events. So the kind of questions that we're answering with these kind of studies are recent weather events due to natural climate variations, or are they due to climate change? And is it possible to quantify the different factors that influence the odds of these kind of events occurring? So like I said, we're just going to jump straight in and look at a particular event. And this one is the heavy rainfall that occurred in Australia over the period of around 2010 to 2012. So during this time, rainfall records were broken from daily right through to yearly timescales. It was the wettest 2-year period on record for Eastern Australia, and the preceding sort of decade-long drought was broken, but these heavy rainfall events did result in substantial flooding and eventually loss of life. So we're going to look at this particular event in an Australian context, and in terms of looking at the relative influences on those records that got broken. So we know that Australian rainfall is linked to ENSO conditions, and during the event that I just showed here, that 2-year heavy rainfall period occurred at the same time as 2 very strong back-to-back La Niñas. So we know that that might have had an influence on the event, but we also know and have heard over the last couple of days that rainfall is likely to change in response to shifting mean climate state. So we're going to ask questions like, was the extreme rainfall that occurred during that time linked to ENSO, or was it linked to the greenhouse gases? And these kind of events attribution studies are really getting at whether some type of events are likely to occur more or less frequently in the future, and can we expect more of this type of event. So that kind of information is going to have implications in terms of how we cope, and I think would make quite different decisions about that if we were expecting this kind of event to become increasingly frequent and severe in the future, compared to if these studies show that it was just an artefact of natural climate variation. So with our Australian example, we're just going to take the first approach, which is just looking at the observations, and then we're going to throw in the climate models and see if we can get some more useful information. And I should point out that this example and a lot of these figures I've grabbed from Andrew King's recent work that's just been accepted. So the observations, that's what I have here, a picture of rainfall anomalies for southeastern Australia, and then a time series for the Bureau. And these both show that it was certainly a lot of rainfall. And then we can look at the observed relationship between ENSO conditions and what's going on with Australian rainfall. And these are our wet years here, and we can see that once again the heavy rainfall is more commonly associated with the La Niña conditions, which is what we had during that 2-year period. And then we can perhaps employ some thermodynamic arguments. So the little distributions I have here show what would likely happen to precipitation in a warming climate, and we can see we'll likely have more incidences of heavy precipitation. So once again, we're back to that heavy rainfall is linked to ENSO, and we're also expecting more heavy rainfall linked to mean climate warming. So we can use all that information, and then we can also look at the climate model results. And in this case, we're using a suite of the CMIP5 models, and I think we've talked about them previously, but a collection of different models that are running standardised experiments that can be used together as an ensemble. So in this first diagram, we have distributions of southeastern Australian rainfall associated with the La Nina years in the black, and the El Nino and neutral years in the red. And so again, we can see that we have more heavy rainfall on this tail of the distribution, which is associated with the La Nina conditions. And next, we're going to compare the likelihood of the heavy rainfall events in that set of experiments with and without strong greenhouse gases. So in this case, we're looking at a historical experiment, which is attempting to simulate the climate of 1850 to 2005 as accurately as possible. And in this case, we've picked out heavy rainfall events comparing rainfall in the early part of that record where we don't have a strong human influence, and comparing it to the later part of the record when we know there is a strong human influence. But if we look again in the tail of this distribution, comparing the strong human influenced distribution, the one in red, with the one that had minimal anthropogenic influences, we see in the tail there's actually very little difference between them. So in this study, it was found that there was little evidence for change in the relationship between extreme rainfall and ENSO, with and without greenhouse gases, but also that the anthropogenic influences had a limited impact on the extreme rainfall. So that helped us pick apart those different contributing factors by using the climate model, as well as all the other information we had available. So this approach has been used for a lot of different examples, and some of them have actually found really clear anthropogenic signals. And this is an example here of the European summer heatwave from back in 2003. So this was an extremely warm summer, and it suggested that it was probably the hottest summer in Europe since 1500 AD. And in France alone, this heat wave was associated with 14,000 extra heat-related deaths. So working out the change in the risk of these kind of events is quite a targeted area of research at the moment. So in this case, and this is the distribution of European summers, and this was the heat wave in question, and I think that this was the next hottest summer on record. So it was really an extremely high record that got broken. And in this case, they compared the likelihood of the summer heat wave occurring with and without anthropogenic climate influences. And that's this plot here, and showing the occurrence of summer temperatures in the anthropogenically influenced model runs without, and the best estimate was that there was a fourfold increase in the likelihood of such a summer occurring due to climate change. So in this case, there was a strong human influence, unlike our example of the heavy Australian rainfall. And this is just a final example of that event attribution using climate models examples. And this case was the UK flooding that occurred in autumn of 2000, and this was another significant event. This was the largest flooding on record since, I think their high quality records began about 1760. And this was once again associated with quite significant flood damage. It was over £1 billion of flood damage, and I think something like 10 or 12,000 people had to be evacuated from their homes because of this flood event. And once again I have more of these complicated risk attribution diagrams that are horrible to read and explain. But this first one is showing the return time of those kind of flood events in autumn for the area, and this line here designates the flood level that was reached during the 2000 event, and this blue line coming up here shows the return time for those events for the model experiments that had anthropogenic influences, strong greenhouse gases, and then these little brown circles show the control simulation where they don't have any human influence. And what you can see is that the return time is vastly reduced. So these events are occurring a lot more frequently in the simulations that have a human influence. And when they looked at the increase in risk associated with this event that could be attributed to the human influences, they found that it was likely it was a doubling of risk. So those kind of examples of the event attribution lead to the next part, because really what they're looking at is not just what factors are influencing those events, but also which ones we can expect to occur more frequently or with greater severity in the future. So next I'm just going to talk a little bit about how we use climate models to look at changes in extremes in these future simulations. So apologies for a few wordy slides, but I just thought it was worth summarising some of the IPCC statements about changes in climate extremes. So these ones are starting off with just general climate, but warming of the climate system is unequivocal, and most of the observed increase in global average temperatures is very likely due to increases in greenhouse gases. And then when we look at particular types of extremes, we can see it's very likely that hot extremes will continue to become more frequent, but we have slightly less confidence in other types of extremes, so it's likely that future tropical cyclones will become more intense. But as it says, there's less confidence in predictions about decreases in the number of tropical cyclones. So these are again just some little schematics of distributions showing changes in extremes with changes in the mean climate. So at the top left, this is for temperature. Temperature, and then for precipitation, this is the same one I showed before. So these are just possible changes, so there's various different things that can happen in terms of changes in extremes, but these are just simplifications that just show nice little figures of what could happen. But when we shift the mean climate, it's possible we get less cold weather and more record hot weather, which is somewhat unsurprising, and again, less light precipitation and more heavy precipitation. So an update on the last IPCC assessment report from the Special Report on Extremes suggests it's virtually certain that increases in the frequency and magnitude of daily temperature extremes will occur by the end of the century, and decreases in cold extremes, which is sort of highlights what we see with these shifts in distributions. But the point of this is that most of these projections come from climate models, and this is one way that we can use climate models to investigate changes in extremes. So these plots here show just some examples of projected changes in extremes for Australia. So we have maximum temperature extremes on the left and precipitation extremes on the right. And sorry, these figures are terrible up there, but just the little box plots show what's expected to happen for a once in 20-year event that occurred at the end of last century. So an event that occurred roughly once every 20 years between 1981 and 2000, and how that is likely to change towards the end of the century when we look at different scenarios. So if we pick out this example for South Australia for maximum temperatures, if we look right at the end of the next century under this high emissions scenario, a once in 20-year event that occurred recently is likely to occur every sort of 1 to 2 years, and even more frequently for Northern Australia. So these are just, there's nothing particular about these examples. They're just examples that I've picked out to show how we can project changes in the frequency of particular extremes, and these are under different scenarios that have been modelled using various climate models. So models provide us with an opportunity to understand climate extremes, which we saw from those examples I gave of attributing the cause of particular examples of extremes to either natural variations or anthropogenic influences, or in some cases a combination of the two. And they also provide us an opportunity to understand possible future changes in these extremes and how they may impact people. But now we have to step back a little bit and look at whether those were legitimate things to do, because we've heard previously about evaluating our models and about potential problems with precipitation in models. So now we're going to look at the representation of extremes and how that depends on the type of extreme and the type of model. And then we can assess whether those examples were good examples of how to use climate models to investigate extremes, or if perhaps they were a little bit misguided. So we've talked through some of the limitations of modelling previously, but in particular, this is just sort of general categories of limitations of models, but when we're talking specifically about extremes, I would say that the simulation of extremes is limited particularly by spatial and temporal resolution and by the poor representation of particular processes. So these little diagrams I have here show that changes in, they're just little schematics showing changes in sort of the components that were included